So in section 6.3, we're going to determine the six trigonometric functions at pi over 4 and list any results on our unit circle. So what you're going to do is you're going to make a unit circle with these values in it, and we want to find what's going on at pi over 4. So let's go to our unit circle. We know this is 0, we know this is pi over 2, so halfway in between there is going to be my pi over 4. And when we were doing degrees, we would have called that 45 degrees. And you can change that into radians and back and forth by multiplying by pi over 180 or 180 over pi. So what we're going to do is we're going to find out what values we get. And it just happens that we get a 45, 45, 90 right triangle. And if you recall, back in the special triangle days, the ratio of the sides were 1, 1, root 2. But we know that this is a unit circle, so this hypotenuse here has to be 1. So I'm going to divide everything by the square root of 2 to get it on my unit circle. And just for the fun of it, I'm going to rationalize, because that's what mathematicians do. So we know the x value is root 2 over 2, and we know this y value is root 2 over 2. So, and we recall that the x value is the cosine, so the cosine at pi over 4 is root 2 over 2. And the sine, which is the y value, is also root 2 over 2. And anything divided by itself is going to be a 1. The reciprocal of 1 is 1. And the reciprocal of, this would be cosecant of pi over 4. The reciprocal of, if we go back here, 1 over the square root of 2 before we rationalize would be the square root of 2 over 1. So this is square root of 2. And the secant at pi over 4 is also square root of 2. So those all came from our unit circle and our special triangle. Now, let's move on to the next one. Make sure you're getting this on your unit circle that you're drawing. I'll probably send you one, a blank one, so you can fill it in too. I hope you got it by the time you're watching this. Determine the values of 6 of pi over 3 and pi over 6. And list any results on your unit circle. So again, we're going to go over here. Ooh, that's bad. Let's try that again. All right, let's try that again, Mr. Otto. There we go. That's better. So our pi over 6 is right here. And if we change pi over 6 to degrees, we get 30 degrees. So I'm going to, just for the fun of it, I'm going to go over here, draw my triangle, call this a 30. It's a right triangle, and I get the 30, 60, 90 right triangle. And we remember this one from our special triangles also. The ratio of the sides were 1 to square root 3. But we know that this is on a unit circle, so we have to divide everything by 2. And we get an x value of the square root of 3 over 2. We get a y value of 1/2. So if I go to my unit circle, this point right there on my unit circle is root 3 over 2 comma 1/2. Well, we know that the cosine is the x, and we get root 3 over 2. We know that the sine is the y, which gives me 1/2. And we also get that the tangent of pi over 6. Now, if I do this, we know that it's sine divided by the cosine. I'm going to do it once so you guys can see it, times the reciprocal. And I get 1 over the square root of 3. And if you rationalize that, you get root 3 over 3. The cotangent at that same point is the reciprocal. And instead of rationalizing it, it's 1 over the square root of 3. Reciprocal of that gives me root 3. And if I go with the secant, we know that the secant is the reciprocal of cosine, so I get 2 root 3 over 3. Rationalize that for yourself. And the cosecant at the same point is 2. All right. Now, just for the fun of it, hopefully you can pause it here and write that down, because I'm going to erase it and do the same thing with pi over 3. Because I ran out of room. And so we're going to start over. We know pi over 3 is a 60-degree angle, which leaves 30 there. So it's the same 30, 60, 90 right triangle that we talked about before, except for it's in a different position. And we know this is 1, this is 2, this is square root of 3 divided by 2 because it's on a unit circle. And I get different values. It's actually just switching the values that you had last time. This time the x value is the half, and the y value, which is the sine, is the root 3 over 2. And our tangent of this is going to be your root 3. The cotangent at that same value is root 3 over 3. And we're going to do the reciprocal of cosecant, which gives me root 2 root 3 over 3. And the secant is 2. All right. So now we have the values for all of the angles in the first quadrant. Let's talk about what do we do with that for the rest of them. Well, all the values that we have here ends up going over there. We just flip them, and when we flip things over the y-axis, the x value changes and the y value stays the same. So on the next, we're going to talk about just filling in a unit circle. So I'm going to take a couple minutes and do that. If this is pi over 6, this is pi over 4, and this is pi over 3, that we just filled in, this is 0. We know that this is going to be the point 1, 0. This is the x value is root 3 over 2, 1 half, root 2 over 2, root 2 over 2, and 1 half, root 3 over 2, and the point is 0, 1. So that was our things that we had in the first quadrant. So when I flip this over the y-axis, I'm going to be getting these points. Well, this one's pi over 2. And we're going to start finding values over here. And then we'll fill in those radians here in a second. So I get negative 1 half root 3 over 2, negative root 2 over 2, root 2 over 2, and negative root 3 over 2, 1 half, and negative 1, 0. So easy enough to flip it over there. And then to finish it off, we would flip that over the x-axis, and flipping it over the x-axis gives me a change in the y value. So all of the bottom would be the same as the top, except for you change the sign on your y values. So now let's get to the trick about writing all the radians in here. So in radians, all we have to do is add 1/6, but we leave out these middle ones. That one we'd leave out. This one we'd leave out. And we'll go back and fill those in a second. So all we have to do is count by sixths. So 1 pi over 6, 2 pi over 6, which of course we simplify to pi over 3. 3 pi over 6, which simplifies to pi over 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, skip it, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and back here is 12 pi over 6. And then to go back and get the ones that we missed, we just count by fourths. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, which is pi again, 5 pi over 4, 6 pi over 4, which simplifies to 3 pi, 7 pi over 4, and 8 pi over 4, which is the same thing. So you can get your unit circle just by doing the pi over 6s and then going back and doing the pi over 4s. And we get the rest of the values on your unit circle just by flipping it over the x-axis, which changes all your y values. All right, so now let's talk about the rest of this stuff. A reference angle, theta prime, is an acute angle with positive measure formed by the x-axis and the terminal side of the theta. So if I have a big angle here, it's not an acute. The acute is this one here that goes from the horizontal up there. And we're going to use those reference angles because I don't need to memorize all the measures all the way around. I can use the reference angles. So my reference angle down in the third is from the horizontal down. In the fourth, it's from the horizontal down. Anytime you're measuring, it's from the horizontal up or the horizontal down. An important property, the values of the 6 trig functions of theta are the same as the values of the 6 trig functions at theta prime. Okay? So, but we got to make sure that our sign is correct because when we do reference angles, we're always going to get the positive one. So how do we know where do we put a negative sign and where we don't? Well, we use the cute little mnemonic device, all students take calculus. In the first quadrant, all the trigs are positive. So sine, cosine, and tan are all positive in the first quadrant. Students starts with S, so we know that the sine is positive, but the cosine and tangent are negative. Here, in the third quadrant, the tangent is positive, but the sine and cosine are negative. And in the fourth quadrant, we know that the cosine is positive, but the sine and tangent are negative. So all students take calculus tells me which ones are positive. Use the reference angle to determine, all right, so if I draw my unit circle and I do my 5 pi over 6, that means that I know that I have a pi over 6 reference angle. And I know that the sine at pi over 6, sine is the y, I know this is equal to a half. But since I'm in the second quadrant, I know that all students take calculus. I know that it's positive in the second quadrant, so it stays a half. Over here, if I go to my 7 pi over 4, which is down there, my reference angle, because I'm going from the horizontal, is pi over 4 down from the 2 pi. So my tangent at pi over 4 is 1. And then I'm going to say all students take calculus. So the cosine is positive, so the tangent would be negative, so that answer would be negative 1. And if I go over here, and I'm going to go with negative 2 pi over 3, so there's my angle. I know that my cosine is the reciprocal, and I know this point down here is going to be a negative 1/2, negative root 3 over 2. And so if my cosine is this, that means my secant is going to be the reciprocal of that, which makes it a negative 2. So it's a negative 2 there. But wait! We could have said, oh, what's my reference angle? Pi over 3. So pi over 3, we know the value up there at pi over 3, and we could have used that. Okay? All right. So let's talk, better stop there.